Good evening, everybody. Welcome to Unacademy. Welcome to our session. I am Sankar Mantina. I did my MTech from IIT Kharagpur. I am here with Network Analysis Power Calculation topic lecture, guys. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertise with the subjects of digital circuits, network analysis, and microprocessors, guys. Right. So let's start the session, guys. Good evening, Prasanna. Just give me 1 minute. Good evening, Saddam. Okay. So in this lecture, we will be doing very good questions on what we call power calculations. So last lecture I have given you theory. Now the power calculation problems we will do today's lecture. And also you will be having some kind of surprise today. Okay, let's see that at the end of the class. Hi Harsha. So let's start. So guys, if you want to plan for Unacademy Plus subscription, sir, a plus subscription क्या है sir? Whatever you are doing here is the YouTube classes which are completely free for you. But if you want to plan for plus subscription, guys, there is some extra advantage. What is the extra advantage with the plus subscription, sir? You have a live classes that is regular daily. You will be having the live classes morning and evening. You will be having, so even you go to college also, it will not be a big issue for you, and you can watch them in recorded also n number of times. Even you join new also, you can watch the old classes and upcoming classes. It doesn't matter, as long as your subscription is valid. You can watch any batch. That is, if you join for one batch, it doesn't matter, you can watch all batches in the Unacademy. That is, if you have subscription for the duration, that is, first you complete the comprehensive, then you want to improve the rank improvement, revision batch, crash batch, everything is available. So we have both the languages, that is English and Hindi lectures completely. You will be having regular exams, unlimited practice, and doubt solving sessions, everything under only one subscription, that is Unacademy Plus subscription. If you want to go for Iconic, you can select if you need a personalized guidance with a digital coach personally assigned for you, and customized study plan, and also personalized test analysis, so that they will be giving you the details about your preparation, how you are going it, how you can go, all those things. That personalized extra guidance will be provided if you go for the Iconic subscription, guys. Whether it is a plus or Iconic 8, you can apply my coupon code Shankar10 to get 10% discount on your subscription. So if you take the 12 months plan, it is originally 30,000 plus, but after applying the 10% discount, you will be getting for 27,225. So if you take for 18 months, it is 34,650. For 24 months, it is originally 44,000, but after applying the coupon code Shankar10, you will get it for 39,600. So without code, you will not be getting the discount. So code is compulsory, guys. It is not for my class, it is for any class. In fact, any GATE ESC or any class in Unacademy, you can use this code, guys, to get the best. If you like my teaching, if you want best guidance from me and our total team, you can apply my coupon code. So these are the prices for Iconic after 10% discount applying my code. Okay. So you can see in YouTube and Plus also, whatever we teach with heart, no doubt in it. But in the Plus, you have the extra advantage because it is a dedicated learning platform. There you can have the more interactive session, more interactive, like if you attend the Plus live class, you love like anything. And another thing, we'll provide regular daily practice problems. We will have doubt sessions and quizzes, everything. Okay, online test series, previous year's practice, everything is free for Plus subscriber students. Okay, in YouTube also, whatever the possible, we are giving that also. So if you want, you can search my profile name in Unacademy. You can message me there for any kind of queries. Okay, so right, let's move. Hanmantra, have you attended all the classes till date? Hanmantra, please answer this question. Have you attended every single class till date? So So right, yesterday class we have discussed some the basics of the power calculations, guys, and now we are going to start the power calculations problems. Just a minute, yes. So average power, everything we discussed last lecture, power triangle, and all so on. So now listen here. This question we have done yesterday, and also we have done this question. I have given this question as a homework. How many of you have done that? Please tell me the answer, guys. What is the answer for this question? Good evening, Sanjay. Tell me the answer for the question, guys. How many of you have done this question? Please tell me the please calculate and tell me what is the right answer. Yesterday I have given this question as homework for you. Okay, see here. Determine the power factor of series RC circuit under maximum power transfer condition. Please tell me, guys. Determine the power factor of series RC circuit under maximum power transfer condition. What is the right answer? How many of you have done the question? Please calculate and tell me. What happens? I am not seeing any comments from you guys. So no one has done the question. Please respond to the class, otherwise it is of no meaning. I can give the premiere of the class. Why to go for live if you are not interested in responding? Please respond whether you have done the question or not done. If you have not, if you have done, tell me the answer. If you have not done, tell me the same thing. Then we can resume the class. So see here, determine the power factor of the series RC circuit. Okay, good. So right answer, Prasanna. So let's go. So determine the power factor of series RC circuit under which condition? Maximum power transfer. See here. This is a question given in one of the IES paper. One minute, sorry. Right. So you have a RC circuit. So here you have a capacitor and resistor. You need to find the condition for maximum power transfer. Okay, let's try. Okay, he asked power factor. Very good, very good. So please listen here. So for maximum power transfer, when you have a resistive load, R must be equal to root of RS square plus XS square. That is the magnitude of ZS, source impedance. So if you take this as a source impedance, R must be equal to magnitude of ZS means what? XC. This is the condition required for maximum power transfer. For maximum power transfer, your R must be equal to XC. Okay, Sanjay, no issue. So, right, this is the condition required for maximum power transfer. Then, so please listen here. What is the maximum power transfer condition में power factor? Please listen. What is power factor of series RC circuit? You take current as the reference, voltage across the resistor VR. Okay. What about the voltage across the capacitor? It is VC. Then this is your power factor. So what is cos phi? This we discussed already in the phasor diagrams topic. That is R by XC. This is equal to R by XC. Sorry. VR by cos phi equal to VR by V. I'm sorry. That is R by Z. Power factor. So what is the power factor, sir? It is R by mod Z. Mod Z means Z of the total circuit. That is R by the root of r square plus x square. But what is r, sir? What is r, sir? R is equal to xc. So x square plus x square 1 by root 2. Okay. So this is the condition for maximum power transfer. Okay. This is the answer, guys. Okay. Just a minute. Okay. Right. So let's move to the next question. So this is the question given in GATE 2018. Let us see how many of you are able to answer it. So try the question and tell me the answer. Try the question, tell me the answer. The voltage across the circuit in the figure and the current through it are given by the following expression. V of t equal to 5 minus 10 cos omega t plus 60 degrees and I of t equal to 5 plus x cos omega t, where omega equal to 100 pi radians per second. Okay. So if the average power delivered by the circuit is 0, find x. Please try it. I will give you 1 minute time. So those who want to try, give a try. Give a try, guys. We have not done this, Srinath. That is a different class. Yeah, tell me the answer. What is the value of x? What is the value of x? Yesterday I have given you the formula when harmonics are present, how to solve the average power. What is the formula I have given? P average is equal to, here V naught I naught, that is a DC, plus VRMS of first signal, IRMS of the omega 1 signal into cos phi, plus and so on. This is what I have given for harmonics. So V naught into I naught is 5 into 5 plus VRMS is 10 by root 2. Okay. Then into IRMS, or if you multiply these two signals, what will you get here is what is that voltage and current, x by root 2. Okay. Into cos phi, cos 60 degrees. Okay. Here you can take minus. This minus 10, so we represent with minus. Okay. This must be equal to 0. So which implies 25 equal to 10x by 2 into 1 by 2. So what is the answer, sir? 10x equal to 100. What is x value, sir? 10. Okay. It is not 5, it is 10. Next question. Determine the power factor. Before this, I want to take one more question. Where is that? Just a minute, guys. Yeah, do this question. It is a 2016 gate. Then we will go for the previous questions. So try this question, guys. This question you can do. Yes, Mohan. Let's leave them. People don't deserve the classes for free. That is the conclusion we can take. Okay, just read the questions. So, what is the right answer? Chaitanya, yes, very good. So, you should take only fundamental here because the harmonics are not present in the voltage, they are present only in the current. So, this part is already 0, you can neglect that. Then, what is the answer? P average is equal to 100 by root 2 into 10 by root 2 cos 60 degrees. So VRMS, IRMS cos by 1000 by 2 into cos 60. Okay, 1 by 2, which will give you 250. Okay, next. Listen here. Determine the power factor of this circuit. Try this question, guys. It is a GATE 2017 question. 2017 it is given. Try it and tell me. Try this question and tell me the answer. Try this. Good evening, Kavya. So right, let's do it. Determine the power factor. Here, network general misconception is sir, network is containing resistor. Yes. So can I say unity power factor? No. Power factor is not cos phi every time, my dear friends. Yesterday we have already discussed what is the definition of the power factor is active power by apparent power. Out of the total power, apparent power mein how much is active? That is what we call power factor. Okay, right. So please listen here. If you take this as the supply voltage, this is the resistor voltage, and now this is the source current, load current. So what is power factor, sir? You can say it is equal to the load power, absorbed power. Load, how much active power is? It is a resistor. Directly you can say VR IR. There is no cos phi because cos phi is 1 here. So VR into IR by VS into IS. Okay. But this should be RMS values. Everything should be RMS in fact. Okay, everything should be RMS. But here you see they are in series. So series mein current is same. IR is equal to IS. So IR IS same. So power factor is equal to VR by VS. Okay, if you see VS, it is a sinusoidal waveform. What about VR, sir? After diode conducts in the positive half, negative half it is 0. Positive half it will conduct, negative half it is 0. So please listen here. Your Vs is a sinusoidal waveform. Vr is a half rectified sine wave. So what is the RMS value of Vs signal, sir? RMS value equal to maximum value by root 2. What is the value of R? VR RMS, sir? It is Vm by 2. We already discussed this in the topic of average and RMS value. Here it is Vm by R2 and here it is Vm by 2. This is half rectified signal. So substitute that. What is the power factor? Vm by 2 by Vm by root 2. Okay. Prasanna Vishnu, yesterday I told power factor is not cos phi every time. What is the meaning of power factor? It is active power by afferent power. Okay, from this you got the formula of cos phi. Don't apply this every time. Here there are harmonics. Sir, it is a pure sine wave, but it is not a pure sine wave, half rectified sine wave. So here, if you represent by Fourier series, this contains the harmonics. This is a pure sine wave. If both are pure sine waves, then you can say it is cos phi. Here it is a rectified signal. There you will get fundamental harmonic component, double frequency component, everything. From that you should calculate. So what is the answer is 1 by root 2. 0.707. If you want lagging or leading condition also, how to say, sir? इसका sinusoidal omega term if you find Fourier series for this, and for this if you find the omega term, then you should compare its phase with the original phase. Then we can say that. Okay, or not for VR, you can say you should find the current. Current is also, suppose see here, during the positive half diode conducts, negative half it will off, so it is a half rectified signal. So current is a harmonic, that is not a pure sine. Voltage is a pure sine. So for the current it contains harmonics. In that, originally, to understand the problem more clearly, you should find the fundamental component, omega component, that is 100 component. For that you should measure the phase difference to get the whether it is lagging or leading condition. Okay, you can try that, you will get the lag condition. If you want, you can check it, but that is not required for the question. So what he asked is only this one. Okay guys, is it clear? Right. So let's move to the next question. Any queries, feel free to ask me, no problem. Any kind of queries you can feel free to ask me, no problem. Chalo. So let's try this question based on that. Let's try this question based on the previous case. Let's try this question based on the previous case. So determine the power factor of the source. So 10 plus 5 sin t, this is your voltage source Vs. Okay, this is your Is. I am giving you time. Please try and tell me the answer. I have given enough hint also. I want you people to try it and tell me the answer. Instead of I am only doing all the questions, you give a try and tell me the answer. Right. So please listen, try it and tell me the answer. I'm just waiting. You can try the question in the same as previous question. Previous question mein whatever you have done same way you can do it and you will get the answer. So you can try the question in the same way as your previous case. You will be getting the solution. Point 707 is not the same answer every time. It is wrong answer. Any other answer? 0.9023, no. Right. Let me do it. Let me do it. So here also power factor is equal to VR into, that is original formula is same, power P by apparent, active power by apparent power. Active power is how much, sir? Here resistor power, that is VR into IR. Okay, by Vs into Is. Here series na, again same condition, VR by Vs will come. Okay sir, up to this I am okay, happy. because IR equal to IS, I cancel it. Then what is the supply voltage RMS value? Supply का RMS क्या sir? What is VS sir? It is 10 plus 5 sin D. What is the RMS of this one? Root of, we have discussed while discussing the RMS value concept. 10 square plus 5 by root 2 whole square. Okay. So this part will give you how much? 100 and 25 by 2? 112.5. We will calculate later, leave it. Now we need to find VR. So let's try to find VR. For finding VR, please listen carefully. How many sources are acting simultaneously? How many sources are acting simultaneously? Two sources are acting simultaneously, sir. We should find the response of the resistor voltage by using superposition. Let's apply superposition here. Just a minute. By using superposition, this input is 10. Replace this with a short. Just a minute, guys. Take only one source. Resistor we take as it is. How much? 1 ohm. This is VR1. Assume network is in steady state phasor domain. And inductor is replaced, capacitor for DC, it is replaced by open circuit. So when it is open circuit, total voltage will be here only. No current flows here. What is this voltage drop? 0. So for DC, no voltage. Okay, sir, no problem. For AC, what is the answer, sir? For AC, it is equal to, say, I take the reference of cos. You can take 5 angle 0 also, nothing wrong. It is a resistor R. Omega is equal to how much, sir? 1. So we replace capacitor with minus j xc. Xc is equal to 1. Because 1 by omega c. Omega is 1, c also 1. Right. So now, what is VR2? What is VR2, sir? It is equal to 5 angle minus 90 degrees into 1 by 1 minus j. That will give me some 5 angle. I am not worried about phase. Leave it by root 2. Okay. What is VR RMS value? If you have a DC RMS value is how much? VR1 is how much? 0. Here you took maximum now. Whatever you get is maximum only. So what is the RMS value of the second part? It is 5 by root 2 by root 2. That is 5 by 2. Because it is a sinusoidal or sinusoidal signal, RMS will be maximum by root 2. Here you took maximum. Whatever you get is maximum only. That by root 2. Okay. So 5 root 2 by root 2 is 5 by 2. So what is VR RMS is 0 square by 5 by 2 whole square. Right. Finally, what is the power factor, sir? 2.5 upon root of 112.5, which will give you 0.23 lead. Okay, so please listen here carefully. This is the circuit given. I applied one source at a time. First, I applied the source voltage. RMS is root of sum of squares of individual RMSs. We know this already in the RMS calculation. I have given that. Then we take only one source at a time. So first source here and second source. When you take the first source, replace capacitor with open because it is DC. Okay, not phasor domain. The second case I took the phasor domain, 5 angle some phase. Okay, this is R2 and this one. So what is the answer, sir? This into resistance by total total reactance, voltage division principle. Some angle we will get by root of a square plus b square is root 2. This is maximum you took, so maximum only you get. Whether it is root 2 or not doesn't matter. What is RMS? Take by root 2 because it is a sinusoidal signal. So 5 by 2 root of this square plus this square. Okay, so this is how you need to calculate the power factor here. So next question. Next question, guys. Rachna, in phasor also you can add it provided you have both magnitude and phase. 3 plus J4, 2 plus J4. That is KCL only. Okay. If you have in this way, you can happily add it. Okay. If the magnitude is given, that is root of 3 square plus 4 square, 5, root of 2 square plus 4 square, something is given. This we never add it. Okay. This we never add it. Right. Let's move. Let's move to the next, guys. In the network shown in the figure, you have this is the gate question given in gate 2014, guys. In the network shown in the figure, a 230 volts power supply is delivering power to two loads in parallel. We have two loads in parallel. The power absorbed by the loads is 10 kilowatt and 10 kilovolt ampere at the power factor of 0.8 leading and 0.8 lagging, respectively. Determine the complex power delivered by the source. Okay, so let me draw the figure given by examiner. Okay, this is the circuit. So this is given by examiner. You have a 230 volts power supply delivering power to two loads in parallel. Okay. The power absorbed by the loads is 10 kilowatt and 10 kilovolt ampere at a power factor of 0.8 lead and lag respectively. First one is 0.8 leading, second one is 0.8 lagging. Okay. Determine the total complex power supplied by the source. Listen here. You see here what is y equivalent is equal to y1 plus y2. Okay, so the complex power S equal to V square by Z equivalent. It is V square into y equivalent. Okay, so can I write this as V square into y1 plus V square into y2? Yes or no? Yes. So here V square into y1 is nothing but V square by z1 for your understanding plus V square by z2, or simply you can say S equal to S1 plus S2. Provided you have both magnitude and phase, don't add only magnitudes, never do this. Okay. So total complex power you can add individual complex power supplied by the source. Now listen. Now listen. In the network shown, a 230 volts power supply is delivering power to two loads in parallel. Okay, these are the two loads connected in parallel. Power absorbed by the loads is 10 kilowatt and 10 kilo VA. Okay, 0.8 lead and lag. So let's find individual S1, S2, find add it. I'll give you conventional way of solving the question which will give you better clarity. Second, I will give you simple shortcut where you can get the answer in 2 steps. Both I will give you. Just wait. Okay. So first one, let me calculate S1. First power given by examiner is 10 kilowatt. You see the units. Is it real power or reactive power or complex power or apparent power? What is this? What is this? 10 kilowatt. What is the meaning of 10 kilowatt? What is the meaning of 10 kilowatt here, guys? Tell me. 10 kilowatt means yes, it is a real power. Power P1 equal to 10 kilowatts, sir. Okay. It is power factor is given by cos phi, which is equal to 0.8. Examiner has given 8 leading. Cos phi is given. First one is leading, second one is lagging. Okay, guys. So please get this basic revised. PQS power triangle. So please listen. What is cos phi here? P by S. What is sin phi? Q by S. What is tan pi is Q by P. These things we should remember compulsory. Okay. Now by using this, I want to find the other powers also. Before that, let's find phi. Phi equal to cos inverse of 0.8. You get 36.86 degrees. Then I want to find P is there. I want to find Q. I want to find Q, so I should find tan phi. What is tan phi? You take phi 1. You do this tan 36.86 something, you get 0.75. Right. So, what is the Q, sir? Q is equal to P tan phi. Yes or no? You know what is Q? P tan phi. So, what is this, sir? P is 10K into 7.5, which is simply 7.5 kilovolt ampere reactive. Then what is S, sir? Very good. What is S? What is S? It is P plus JQ or P minus JQ. You should comment P plus JQ or P minus JQ. What is S, sir? Is it P plus JQ or P minus JQ, guys? Tell me. Yes, S is equal to here P minus JQ. Why P minus JQ? Because examiner has given it is leading. So P minus JQ, that is what is P, sir? 10 minus J 7.5 kilovolt ampere. Done. This part is done. Next, please listen here. Second case, go back. He said it is a 10 kilovolt ampere. Which power it is? 10 kilovolt ampere. Second load ka power is 10 kilovolt ampere at a 0.8 lagging. 10 kilovolt ampere means which power? 10 kilovolt ampere means which power? It is nothing but apparent power. Very good. S2 is equal to 10 kVA. And your power factor is equal to same answer 0.8 cos pi. Then sin phi 2, you just calculate from the cos, you will get 0.6. Right? Then it is a simple question again. What is P, sir? S cos phi. S cos phi. So what is S, sir? 10K into 0.8. It will give you 8 kilowatt. What is Q, sir? S sin phi. It is 10K into 0.6. 6 kilovolt ampere reactive. Then what is complex power S2? Now it is lagging. So you should take P2 plus JQ2. Examiner has given lagging. So it is, what is the answer? 8 plus J6 kilovolt ampere. Now what is the overall S, sir? Overall S equal to S1 plus S2. What is that? 10 minus J 7.5 plus 8 plus J6, which will give you 8 minus J 1.5 kilovolt amperes. Okay, this is the final answer. Sir, इतना करना चाहिए. This much analysis is required for the simple question, sir. This analysis I have done because to show you how to get all powers from one power relation. But no need to do this much. I will give you easiest way. Without doing this much, I will show you how to get the answer. Listen here. What is the complex power S, sir? S equal to S1 plus S2, sir. Okay. What is S1, sir? What is S1, sir? Please understand here. P1 by cos phi 1. Okay. This will give you magnitude of the S1. Okay. Similarly, examiner has already given the magnitude of the S2. So, what is S1 can be written as magnitude of the S1 angle phi 1. What is S2, sir? S2 ka magnitude is already given examiner and angle phi 2. Cos phi is given cos inverse phi. Overall S equal to directly S1 plus S2. In this case, only two-step problem. But one mistake I intentionally done so that you will not do the mistake again. So please tell me what is the mistake in this page? Is there any mistake in the page? Yes, yes, yes. You should take minus here because it is lagging. Because it is lagging, you should take minus, guys. You should take minus. Sorry, leading. Because it is leading, you should take minus and do the problem. Okay, then remaining is same. S equal to S1 plus S2. Provided you should have both magnitude and phases, definitely we can add it. Okay, I'm not adding S1 mod and S2 mod. I'm not adding it. I never say S equal to S1 plus S2. If I say like this, it is definitely wrong. Okay, so right. Let's move. So this question I am leaving you for homework. We will discuss tomorrow. This question I am leaving as homework for you. This question I'm leaving as homework for you. You can find the current value I that I'm leaving. Okay. So chalo next. This one. Before going to this, I want to give you one question. Just a minute, guys. It's a previous IES question. I hope everybody here can answer it. Let's see. Right. So the question is determine the reactive power supplied by the source. Okay. So try this question, guys. Tell me the answer. Tell me the answer. Very good. So it's a very simple question. So because the net reactance is zero, the power will be equal to zero. That here what happens generally physically what happens, inductor capacitor will exchange energy with each other. So source is delivering only to resistor. This is what we call unity power factor, resonance condition, all the conditions. So inductor capacitor will exchange with each other. Source is delivering to resistor only. Source is delivering to resistor only. Okay, is it clear? Chalo. Next, I want to take one more question now. Sine omega naught t plus. So try this question, guys. This question will be interesting. So this V of t is applied to a pure inductor. Okay, this V of t is applied to a pure inductor. Find IRMS. Find IRMS. Okay, if 1 minute, I'm changing the question. If only V naught sine omega naught is applied, okay, then IRMS equal to I naught. Then find IRMS for above case. So try this question, guys. I will give you options also. Okay. So please read the question. Try to answer it. It is 0 I naught 10 times I naught root of 1 plus 2 square plus 3 square plus 4 square into I naught. Let's see what is the right answer. Try this. See here, when the input signal is V naught sine omega t, your IRMS of the current is I naught, sir. I naught. Okay. What is the IRMS? If you apply V of t equal to, what is that? V naught sine omega t plus 2 V naught sine omega V naught plus 3 V naught sine 3 omega naught and 4 V naught sine 4 omega naught. Tell me, guys. Is this the same 0 10 times I naught or root of 1 square plus 2 square plus 3 square plus 4 square I naught? What will be the right answer? So most of you are giving B as the answer. Why B? You can do by phasor or by using any method. You will get the same answer, guys. Let me check. Let me show you. Answer is D. Let's try. Okay. So this is the input given. What is the current I of t, sir? L di by dt. So what is the first? Only this one is applied. What is the answer you will get? L into V naught into, okay, sorry, L into V naught into d by dt of sine omega naught t is omega naught cos omega naught t. This I am saying as I naught. Okay, for this, I'm sorry, for this is your I of t. If only V naught sine omega naught t is applied. Okay. So if only V naught sine omega naught t is applied, okay, then this is the answer. What is the RMS value, sir? IRMS is equal to, it is V naught omega naught L by root 2. Okay, this we replace with I naught. Chalo sir, ठीक है sir, no problem. Second case में, okay, second case में what will be the RMS value? This is for I1. Okay, 1 minute. Current is applied, voltage is applied, no? I'm sorry, just a minute, guys. Voltage is applied, he want current. I'm sorry. Yes, don't worry. So first one, you take V1 equal to V naught sine omega naught t. Then what is the current I1, sir? It is V naught by j omega L, okay, into sine omega naught t. So what is I1 RMS, sir? It is V naught by omega naught L by root 2. Is it okay, everybody, now? It will give you V naught by root 2 into omega naught L. Everybody, is it clear up to this? Now, this is given by examiner as I naught. Okay. Second case में what is the inputs are? Second case what is the inputs are? V2 equal to 2 V naught sine 2 omega naught t. Then it will be equal to, you will get 2 times V naught by j times 2 omega naught L into sine omega naught t. Yes, yes, listen here, listen here. So now what happens, sir? Here 2 omega naught, sorry, here 2 cancels. It will give you same answer again. This is I2 is the same as I1. Is it okay, guys? I2 will be same as I0 because the 2 cancels here. It will be same as I1, and your I2 RMS is equal to I1 RMS. That is equal to I0 only. So you need not calculate the remaining things. Similarly, I3 equal to I4 is equal to I1 only. So what is the RMS value is the same as I0. So what is the overall RMS value? It is root of, tell me, I1 RMS whole square plus I2 RMS whole square plus I3 RMS whole square plus I4 RMS whole square. We discussed this already in the what we call power average RMS. So I0 square plus I0 square plus, which will give you 2 times I0. For what is the answer is 2 times I0. Is it okay, guys? Any doubt, please feel free to ask. Got it? Yes, 2I0 is also given in the options. Options are 0, 10I0, 2I0 and root of that much. So what is the answer is 2I0. Chalo, let's take a quiz now. Let's take a quiz now. So if you guys are ready, I am planning to conduct a quiz. We have few more questions which we discussed in the tomorrow class. Before that, get ready, guys. So I am taking 10 questions for you. Get ready for the quiz. So just a minute. Just a minute, guys. Yes. Right, guys. So we can start. So this is the quiz code, guys. I hope it is visible. So what is the quiz code is 268835. Go to Unacademy app, guys. Go to Unacademy app. Go to tests. Okay, open the Unacademy app. Go to tests and just apply this code 268835. Join the quiz is the process. Okay, then I will start the quiz. Process is very simple. Only one student join. Remaining, go to Unacademy app. In the Unacademy app, you have the icon test. Go in the bottom. Okay, here in the bottom you will be having test. Go to test. There you can go to test. Join the quiz and enter this code. Enter this code. Enter the code of 268835. Once the other students are also joins, then we can start. Tomorrow also I will take some surprise quiz for you. So it will be quickly revising the things, guys. So let me start the quiz. You people are joining. So I'll wait for 1 more minute. Okay, let me start. Shall I wait? Start the quiz. 5, 4, 3, 2, 1. Chalo. Your first question is loading, guys. You can attempt the quiz directly there. So for the parallel RLC circuit, which of the following statements is not correct? Bandwidth is given. At resonance, input impedance real. At resonance, magnitude of the input impedance attains minimum. So you can try. This is the question we discussed from the class only. Yes, last 20 seconds. 5 seconds. Done. Okay. Let us see how many of you have given right answer. Very good. So these are the people has given right answer. Right. Next question. So in the series RLC circuit, R value is given, L value is given, C value given. The lower half power cutoff frequency. It's a previous gate question given in gate 2002. Everything is from our classroom discussion only. So 40 more seconds, guys. I have given the formula, direct substitution of formula, nothing great. If you have your calculator in your hand, that is sufficient. So you can recap that bandwidth by 2 something I have given. You can try that. Last, done. So very few questions, we people 21% gave the right answer as B. Let us see. Prasanna Vishnu, first rank right now. So the next question. For a two-port network defined by the following pair of equations, I1 is given, I2 is given, its impedance parameters are. It's a very simple straight away question. He has given y parameters, he is asking z parameter. Guys, you can do it. So 30 seconds more. Guys. Please don't comment. You attend the quiz directly there. You attend the quiz in the app better. It's a mixed from all the topics, guys. So last few seconds. Good. Around 60% gave right answer now. Very good. Chalo next. Nice. Again, our topic. The power consumed by the resistor is. What is the power consumed by the resistor, guys? The 2 ohm resistor consumes how much power is the question. This question is good. You need little math. Maybe time may not be sufficient, but try. Give a try. Give a try. Definitely it requires little more time. I told already. When signals are same frequency, what to do? First what to do, then what to do. Okay, signals are of same frequency. First thing we should do is, because it is last 5 seconds, I'm saying that. Okay, so first you should convert into a single frequency. Simplify by adding in the phasor domain. Good. 40% gave. Again, Vishnu, Shivam and Sanjay are in the top 3. Pavanji, Arpit and Mahendra, Madhulakshmi, Rachna, okay, Shiv and Mahesh. Next question. Yes, this question does not require much time. Most of you can do it. This. The Norton's equivalent of the circuit across AB is. Last 50 seconds. It is also from our classroom discussion only. Be careful. Mainly with the first two options. Right. In this question, RTH is infinite, guys. RTH must be infinity. Open circuit, no resistance will be present. So, 5 questions are completed halfway through. So, the remaining half we are going to do now. So if the current I of 0 equal to 2 amperes, inductor current initially 2 amperes, determine I of t. This question we have done in the marathon session already. It is a dependent source. It's a dependent source V equal to 4 times V. Find the resistance of the dependent source, then your job is done. Find the resistance offered by the dependent source, then your job is done, guys. That is the hint I can give. Hi Kamle. Find the R equivalent. Very good, guys. Very good. So the resistor will give you minus 4R and R minus 3R is the R equivalent. Then tau is equal to L by R. From that you can do the question. Chalo next. We are moving to the next question. So find the time constant. Again the question from transients. L equivalent, you know, find the R equivalent, job is done. Find the R equivalent, your job is done. It is a simple question. Yes, you can do this question easily. Mamata, you should go to Unacademy app. There you need to attempt the test. I have already given the code in the starting of the lecture. There you need to enter the code, then you will be getting it. So the code is 268835. Go to Unacademy app. In the bottom you will be having tests. There select it. Attempt the test. Join the quiz. Enter the code. That's all. So I hope you have done this question. Here also dependent source is there. Its voltage by current will give its resistance by, it is minus 8 plus 2 minus 6. L equivalent by R equivalent will give you the answer. Why very less number of students gave right answers? Don't quit the quiz. Last 3 questions. It is a previous gate question only. Last 3 questions. Last 3 questions. Here this is voltage. See here, this is voltage, independent source. It is a dependent source of 2 times small v. Be careful. So last few seconds, guys. 20 seconds left. Last 15 seconds. Chalo, done. Only 20% gave the right answer. So finally Vishnu is leading the total and Shivam also. Fenil, top 3. Let's see the remaining. Last 2 questions, guys. So take it as an exam so that it will make the practice. Okay. So please do it. For maximum power transfer, what is the value of the load resistance RL? You can do this question. So last 30 seconds, guys. So this will make you quick revision of all the topics. Tomorrow also I'm planning to take one more quiz for you. Let's see. Very good. This is a simple question. R must be equal to mod z. Right? So the last answer, last question for today's quiz. This is straight away from our classroom notes only. We have discussed this in the regular class also. You can think of some hint like think like a pi network, something, write the equations, whatever may be. I'm expecting more right answer for this question. I'm expecting more right answers in this question. So the last 30 seconds of today's total quiz, I'm expecting more and more number of right answers, guys. Let us see how many of you will give the right answers. So let us see. Pawan Kalyan, have you attended all the classes? Not most. First attend every single class, then you can have the right to ask the questions. Okay. If you don't attend all the classes, there is no use of asking. Attend every single question class, then you can ask anything. I can definitely help you. Okay, guys, that is about your total quiz today. So around 25 people has participated. So Vishnu, you are the winner. So Pawan Kalyan, only 2 topics are left. You just wait. I will give you the details. Okay. So Arpit and Shivam are the top 3. Fenil, Madhulakshmi, Vamsi, Mohan, Mahesh, Kamesh, and Pawanji are the top 10. And Chaitanya Sai is the 11. Right. So let's move to our class. Let's go back to the class. Okay. So let's move here. One more thing I want to say is tomorrow also we are planning. I will plan one more quiz so that it will make quick revision. Tomorrow I will finish the power calculation. After that, what is the leftover topic, sir? It is only this part: magnetically coupled circuits. Okay, graph theory, synthesis. Synthesis means not much. Whatever required for your gate exam, that we will discuss. Then 3 phase. Only these small miscellaneous topics are left over. Remaining your syllabus is completed. Okay. Is it clear, Pawan Kalyan? You are there? Except this, your total topic is there. It may take hardly 5-6 sessions or 7 or 8 sessions maximum. I will see when to take this part. Tomorrow, I will complete the problems of the power calculation. Some good problems I will solve and I will take a quiz also. Okay. When current source is open, what I didn't understand. I think maybe infinity. You are asking about the Thevenin's question. Prasanna Vishnu. For that, the impedance must be infinity. For Thevenin's, I am saying. Okay, guys, you can attend. See here, my intention is to give you the best possible. To complete the syllabus is I can finish this in 1 hour. Power calculations. No one will teach you this much elaborately. You check anywhere. These many number of questions in networks in power calculations. I can challenge you. You cannot get anywhere. So we are. I am giving you the best possibility. Utilize it properly. Okay. So we are taking intentionally more and more time so that whenever you see the playlist tomorrow, it should be like a complete package, not for today or short term goal. It should be like a long term goal. So except this, remaining all topics will be completed by tomorrow. These things we will take in the next month. Okay, let's move. So I have already completed 2016 to guys 2016 में two papers, 17 two papers, 18, 19, 20. All these years networks previous are completed. So I am planning remaining also in this 2-3 days. I may complete 11 to 15 also. So these are available in this channel, guys. You can go and watch. Total solutions are available. Okay. Okay, Prashant. All the best. So follow our channels and share with the maximum, guys. Thank you, thank you, thank you very much. We will meet again tomorrow. Bye bye.